Okay, let's have a look here. Write down the coordinates at the center of the circle. Okay, so let's complete the square. That's x minus 2 squared plus y plus 1 squared. So that's x squared minus 4x plus 4 plus y squared plus 2y plus 1. That's equal to 25, 5 squared. So the circle is at 2 minus 1 with a radius of 5. Verify that that is a point on the circle. Okay, let's sub it in. 1 squared plus 3 squared plus 4 plus 6 minus 20. That does indeed equal 0. Verify it. Okay, so we're done with that. The tangent t to the circle P, to the circle at P, cuts the x-axis at Q. Find the coordinates. Alright, so you've got a circle here at 2 minus 1, radius 5. So, whoops, no, a bit off. And P is minus 1, 3. So there's a tangent here. Cuts, where does it cut the axis? So I'm going to have to find the equation of the tangent. So I'll need to get the slope. 2x plus 2y dy dx minus 4 plus 2 dy dx equals 0. 2x plus 2y dy dx minus 4 plus 2. Okay, and the x is minus 1. So that would be, and y is 3. So that's minus 2 plus 6 dy dx. And the dy dx is actually the slope of the tangent. Minus 4 plus 2m equals 0. So that means m will be 6 over 8, which is 3 over 4. So the equation of the line is y minus y1 equals m times x minus x1. But it's where it crosses the x-axis, so that means y is 0. The 3's cancel. So you get minus 4 equals x plus 1. So x would be minus 5 and y would be 0. So that is the point Q. K is a line through Q, perpendicular to T. Verify it's also a tangent to the circle and find its coordinates at the point of contact. Alright, so actually I didn't quite draw that quite right, but it's also a tangent. So that should mean that the perpendicular distance, okay, I might have to draw this a bit more accurately. Right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so Q is at minus 5, 0. P is at minus 1, 3. The center of the circle is at 2 minus 1. And then P is a tangent. Ugh. So, looks a bit like this. It's a tangent that crosses the axis at Q, and then there's another. It's also another tangent there. I know I've drawn it. Look, oh, and it's perpendicular. K is a line through Q, perpendicular. So I know the slope here is 3/4, so it means I know the slope here is minus 4 over 3. So it means every time I go out 3 units, like here one, for example, 1, 2, 3, I have to go down 1, 2, 3, 4 units. It's not quite the scale, as you can see. So the first thing I want to do I think what I'll do is I'll find the equation of that line and prove the perpendicular distance is 5. So the equation of the line would be y minus y1 equals m times x minus x1. So that means 3y equals minus 4x minus 20. So 4x plus 3y plus 20 equals 0. That's nice to see, the 3, 4, because I know what's going to happen. We're going to get the 5 in the perpendicular distance formula. So let's calculate the perpendicular distance. So the perpendicular distance between that line and this point here at 2 minus 1, that should be 5 if everything has gone according to plan. So that would be 8 plus 3 times minus 1 plus 20 over root 4 squared plus 3 squared. That is modulus of 25, isn't it? Over 5, which is equal to 5. So therefore, it's a tangent. K is the line through Q. Verify it's also a tangent to the circle and find the coordinates T. Find the coordinates of T. Q, I just need to write it down, is at minus 5 here. Okay. What'd be the best way to get the coordinates? If I draw a triangle here, does that help? Yeah, because I know that this side here is 5, and that's the distance. That would be the square root of 7 squared plus 1 squared. So that's the square root of 50. So if I draw this situation here, that's root 50. That's 5. So I think that would have to be 5 as well, wouldn't it? Yeah, it would be. And because the slope is 3 over 4, what that would mean is I'd have to go out 3 and down 4. That would be 5. So yeah, all I have to do is take the point minus 5, 0, and then subtract 3, 4 from it. So that would be minus 8 minus 4. And I can check that that's right by calculating the distance. It should be 5. So we'll just do a quick check. Check. So the square root minus 8 to 2, that's 10 squared. And then 3 squared. No, that doesn't look right, does it? No, I've done something wrong. Oh, I'm not subtracting 3, 4. Sorry, I'm just subtracting, I'm adding 3 and I'm subtracting 4. So, yeah, I went 3 right and 4 down. So it should have been minus 2 and minus 4. Okay, good thing I checked. Let's check that out. So now the distance from minus 2, minus 4 to 2 minus 1. So that would be 4 squared plus 3 squared is the distance, and that distance is equal to 5. So yeah, we found the correct point down here. It is minus 2 minus 4. Okay. Whew. Calculate the ratio, the area of S and the area of the circle on PT with PT t as the diameter. And t is here. So PT is the... okay. All right, this is quite a long question. PT is the diameter, so we'll get the area of circle S first. So the area of S would be pi r squared. And then we need to get the area of the PT triangle, which would be pi r squared. So the radius would be half the distance between P and T. So that's square root, and what was P? P is -1 3 down to -2 -4. So that'd be 1 squared, and then 7 squared. Okay, so that's root 50 divided by 2 squared is 25 over 2. So the area of S to the area of PT would equal 25 to 25 over 2, which would be 2 to 1. So the S is twice as big in area as the second circle, PT. Right, that question felt longer than it was, but I think I've managed to get everything. Write down the coordinates to the centre of the circle, find the length of this radius, verify the point on the circle, the tangent t to the circle at point P equals the x-axis q, find q, k is the line through q perpendicular to t, verify that k is also a tangent, and find the coordinates t, calculate the ratio. Yeah, alright, that's another circle question in the bag.